Alright, so what we've covered so far with graphical user interfaces is how to create some of the objects that we might use inside of a GUI. But we haven't really covered yet how to make a consistently opening GUI so that we could just run one thing and have everything open. So that's what we're going to tackle next. So if we make a new script here, start it as a function, and I'm going to call it my GUI. Alright, it's not going to take any inputs, it's not going to have any outputs. And I'll just save this one. Now while we're at it, and basically all we have to do is the commands that we're writing into the command window, just write them inside of a script or a function, that way every time that they run, they will be created. So start off with my fig is equal to figure without an I in it. Alright, so this one, open a figure window. I'm struggling with the word figure this morning. Alright, so this one is going to open up the figure and store the handle so that we can change any of the properties that we might want to change. Now a figure by itself isn't particularly useful. We need to put buttons and whatnot onto it, and perhaps even an axis. Alright, so the next thing that I want to do is I'm going to put in 3 text boxes. Alright, so I'm going to call them as UI controls. I'm going to show you a little trick when I do this. So create some text boxes. Alright, so text boxes come under UI controls. We've seen them a few times now, and let's create them. So text box A equals UI control. Now we haven't done this yet, but I'm going to show you now. We can actually name some set some of the properties when we're creating them. Alright, so I'm going to change the style of this one to a text box. Alright, so all well and good. Then we'll probably also change the position of it. And position is a 4-element array. This one I want it default position for the first one is going to be fine. The other ones are going to be higher up. So we'll do that in a second. So that one, we can make 3 of them. Alright, so B and C, because we need unique names for all of them. And the previous one, so the default position is 2020 120 20, I think it is. Let's just go up here to where we changed that before. Scrolling up 2020 60 20, sorry. Alright, so position is now going to be so it's 20. If the first one is 20 from the bottom and 20 high, then we need it to be at least 50 from the bottom. So it's the distance from the left first, the distance from the bottom, and then 60 20. Alright, so it's going to be the same size as before. Do something similar for this one. 20. So this one's going to be 20 high, so 20 plus 50 is 70, so let's set this one as 80, and then 60 20. And let's just see what happens when we run this guy. So we run this, and while setting the style property invalid enum, so it's not text box, what is it called? Let's just create one quickly. UI control A is equal to that. Show all the properties. So whenever you make a mistake like I do all the time, We can check it out in here. So it's just text apparently. So it's not text box, it is, oh no, it's edit. I'll go back and just show you that quickly. So text would just be a solid text. This is a edit box. All right, so we change this to edit, edit, and edit. When we run this, we've now got 3 edit boxes. Now, this window might be a bit bigger. We could make these bigger, but we'll get onto that in a second. Let's now put an axes onto this guy. So if we call, what do we need? We need a plot pretty much, but we can't plot anything yet because we don't have any data. So an axes, so my plot equals plot. Not sure if this is going to work. If I run that one, no, not enough input arguments. So close U. Now each time we run this function, we're going to get a new figure window. So keep that in mind. Help axes, I think, is the other function. So it creates an axes in an arbitrary position. So then we can call this axes function. It will create the axes object for us. So axes, and we need a position. And where are we going to put this? So we can put it, I know the second value is going to be 20 from the bottom. We can make it like a 300 by 300. We just need this first position. So how far from the left? These boxes are all 20 from the left and 60 wide, so that's 80. So 20 plus 60 is 80. So let's make this one about 100 from the left. And let's run this and see what we get. We get nothing yet. All right, so it's apparently there though. So this now exists, so we know where plot is going to be plotted when we have something. So what I actually want to do with this is do my favorite example once again of having a parabola being plotted, and these 3 text boxes are going to be my A, B, and C. And we'll be able to change the plot just by changing these values. All right, so just going to change the name of this one to be more consistent. My axes will be that. And what we need to do is have a callback for all these UI controls so that when we edit the values, it updates the plot. But what we also need is default values. So I'm going to set all the default values to be 1. And what I'm going to use to store the values is the string property. So with a edit box, the string is the value inside of the box. So if we go string as the property and then actually give it a string, so a string of 1, that works out fine, something like that. And we'll do that with all 3 of them. So we've now set default values, so when we run this, we can see we've got 1 inside of all of those edit boxes. All right, so we next need our callback. So I'm going to create that as a sub-function. Now, when I create it as a sub-function, that means I get access to all of these variables inside of that sub-function. So it makes it really easy to update values and whatnot. So I'm going to put an end for my original function, which is what I need, and then I'm going to create a sub-function. So my callback, we need to, we don't actually want to call it my callback, call it my CB. So my callback already exists as a function. So I'm going to create the new one, and the 2 inputs that we need for a callback function are the object that the callback is called from and the event data. So we just always need to include at least these two. If you look through the help menu, it tells you how to include more if you need more, but you don't always need more. All right, so what I want my callback to do is call plot whenever any of these are changed. So what I first need to do is get the values inside of the strings of these and change them to be actual numbers instead of strings, and then use those to generate data for the plot. All right, so let's get the values for A, B, and C. So val A is equal to tb underscore A dot string. So that returns the string, and then we string to double of that. And pretty much do that 2 more times for B and go away, C, and B and C. So we now have those values converted to a number to store into there, and we should be able to use that to create our plot. So y is equal to a anonymous function. I just find this a really easy way. Val A multiplied by x dot power 2. So x is always going to be an array of values. So we use the dot power plus val b multiplied by x plus val c. All right, and x is equal to linspace between -10 and 10, -100 in size, plot x and y of x. Okay, so I forgot a comma there, so I'll save that, and what I need to do now is actually set the callbacks for each of these functions to be that sub function. So callback, and that's going to equal at my CB. All right, so add this last set of properties to this one. Put the comma in here, or else it's going to give me an error. So we'll save that and run it. So nothing happens. Cool. I just want to check that this is actually being called, so I put my breakpoint in here. Do that. So this is definitely being called. Plot should be getting called, but it's probably not. It's not in that one. Okay, I just want to disable. Clear. That's better. All right, clear them. Okay, so obviously my axes is not being created. It should have the right values. That looks fairly correct. I just want to see if that's visible. So if I go my axes, yep, see all of this, is it visible? There's a property that's called visible. It's visible. If I change that to the top layer, maybe. Parent is definitely the right one. It's no parent. Let me just check this. I'll pause this video and then continue. Okay, so I worked out what the problem was. And what it is that when creating an axis, it seems that the units are defaulted to normalized. So normalized units are between 0 and 1, and 100 means I'm 100 screens to my right, which is obviously not what I wanted. All right, so I set position, not position, I set units to equal pixels. And now when I run this, I should get my plot window. There's a little bit of overlap here because the left side of the axes rather, is this line here, and it creates its own object for what xtick label and ytick label should be. So we should move this over to the right a little bit more. So I'll set this to 120 and move it up from the bottom. So I'll make it 30. I'm not going to rerun it yet, so this will change the next time I run this. So I'll actually just close and run this again, and we can see we've shifted a little bit. Now, we haven't got any plots yet, so the first time that we change one of these values, we do, so -3. As we can see, this is our A value down the bottom, this is our B value in the middle, this one is our C. So there we have it. So we have a very simple graphical user interface. Now, one of the problems that we're going to have is when we're resizing, things don't scale nicely. And that's where you need to start changing the units and handle it very explicitly. It's always a really big problem trying to get things to scale nicely. So usually you just fix the window size and that sorts out the issue. But yeah, so the next set of videos, I'm going to start going through Guide. And Guide is a nice tool that allows us to create graphical user interfaces.